All right, so this support workshop was triggered from a couple of questions, either through the support channels or in the community Slack, about how the action container images work, some of the limitations, the problem we were actually trying to solve with this feature, and potentially some of the issues we'll see in future coming through support. So to start with, I kind of just wanted to run over why these container images were created in the first place. And if you can imagine a Helm deployment in Octopus today, which is going to be this Helm upgrade script here, it actually revolves or relies on a whole bunch of third-party executables. So if you can imagine that we were maybe deploying to an EKS cluster in Amazon, what we would need for a Helm deployment to complete would be the Helm executable itself, and that can be either version 2 or version 3. And actually, it's not even that simple. Version 2 was very picky about the particular version of the client. It had to match, I think it actually had to match exactly with the version of Helm that was running in the cluster. But for this argument, we'll just say that we had version 2 or version 3. And then we also needed to have kubectl to interact with the Kubernetes cluster. And then on top of that, we likely had to have an executable provided by AWS to complete the authentication part of the Kubernetes access. So just to get our Helm chart deployed to a cloud cluster, we're looking at probably 3 different executables. Helm itself has 2 different versions, and all of these executables are OS specific. So it starts to balloon out the number of executables and the combinations that we needed to leverage in order to do these deployments. And so initially, way back when Octopus only really deployed to Azure, it was quite simple to keep on top of all these executables that we needed to distribute. All the Azure steps ran on the Octopus server. The Octopus server could only run on Windows, so we really only had one thing to distribute. But as we've increased support for other operating systems and other platforms like Kubernetes, the sheer number of tools that we need to execute as part of the deployment has just grown exponentially, really, to the point where it's no longer feasible for us to start shipping these or continue to ship these in the Octopus product itself. And so the answer that we came up with was these execution containers. And so the way they work is that we have a number of versioned Docker images, and these Docker images contain all the combination of executables that we need for the particular operating system. And so the benefit of this is that it allows us to release new versions of these tools independently of Octopus itself, because the images that we release are versioned. Anyone using the old versions can continue to use the old versions. They won't get a bump to a new version of a tool that they didn't expect. And so that increases the compatibility and reduces some of the surprises that happen when we bump these version images. And also, because they're just Docker images, people can create their own or customize the Docker images that we provide. And that also gives the end user a lot of flexibility there to customize any particular version that they may need of a particular tool. Some of the challenges that we're seeing, though, is that people are, or it's tempting to try and use this feature in a way that it wasn't designed to be used. Docker has this idea. It's kind of one of the selling points of Docker, actually, that it removes a lot of the abstraction between what's in the Docker image and the machine you're working on, and it gives you the sense that you can kind of just run Docker anywhere and it will run the same, and you don't really have to think about it. And so that's potentially true when you're developing your own custom application and shipping it as a Docker image, but it doesn't really hold for the use case that we created these images for in the first place. And so there's a bit of a disconnect between some of the expectations and some of the reality of these images. And that's what I wanted to dig into today, just to make sure that the support team was aware of why things work the way they do, and why people may be trying to use this feature in a way that just won't give them the results that they expect. So one of the things to understand before we go any further is how Docker images actually work. And there's two kind of entry points into a Docker image, or there's two ways that a Docker image will execute a bit of code inside itself. And that's the whatever's been referenced through the command argument, which is the CMD argument that's defined when an image is created, and the entry point. And so these two things kind of do the same thing, but there are subtle differences that make it that we need to be aware of, because it starts to play into how these octopus container images work. And so what I have here is just a runbook, and this runbook is going to run Docker inspect. I'll just pull up the code here. So it pulls down the image and then runs Docker inspect on it, and Docker inspect returns a JSON blob with a lot of details about how that Docker image was constructed. And I've run that against, if we go over here, so I've run that command against the Octopus CLI tool. This is a container that we've shipped for some time, and it just embeds the Octopus CLI. And if we go to the results of the Docker inspect, what we want to look at is the config here. This section here, and we can see the entry point and the CMD. And so what these two commands do is, so the purpose of the entry point is really to create a Docker image that can be treated like any other executable. And so in this case, we've leveraged entry point as a way of creating a Docker image that exposes the Octopus CLI, much like you'd expect to just use the CLI executable downloaded natively for your particular operating system. And we can see the entry point here is calling .NET and the Octopus DLL. And this means that, if I just pull up a terminal window here, we can do things like this: Docker run, then run the tool container that we've got here, and then these arguments here are passed to the Octopus CLI, much in the same way that you would pass it straight to the Octopus executable. So as you can see, that's listed the help there. And if I did, pretty sure I've got this installed. Yeah, and so that these two commands are kind of they're basically equivalent, passing it directly to the executable and passing it to the entry point of our tool container here. And so that's the point of entry point. What you can define also are this command argument here, and this would set default arguments to be passed to entry point. So you can imagine if we built this container slightly differently, the default command might be help, for example, and that would mean that if I ran this command here with no arguments, this command here would be the default arguments passed to the entry point. So the takeaway of this is that if I pass arguments, if I've passed this here, this overrides the value here. And so Docker exposes this idea of overriding command line arguments quite easily and naturally. It just looks like a standard executable call. While you can override the entry point, it's a little bit more advanced and it's not typically something that you do. And we don't override the entry point when we run the workers in a container. And we'll see why that's important later. But the thing I want to call out here is that if a Docker image has an entry point defined, Octopus won't override that when it's running the worker in an image. And that's significant because it means a lot of the images or Docker images out there today aren't going to work as we expect. The other thing we need to be aware of is the dependencies that Calamari have. Because it's a .NET Core application, it's almost portable, but the environment, or certainly the Linux environment that you're running it in, has to have a couple of additional dependencies already installed. Libicu is one that comes up a lot. And if this operating system dependency isn't installed, then Calamari just won't function correctly. And what we'll find, I think, with a lot of the existing Docker images out there is that they don't install these third-party libraries. I mean, one of the points of, or certainly something a Docker tries to achieve is minimal, reducing the size of the Docker images. And that means people don't install things that they don't particularly need. And libicu is just one of those things you won't find very often in existing Docker images. The other thing to point out is that Docker images kind of come in two flavors. So we have this, just copy this, oh, that one. So there's this library called MUSL that's pronounced muscle. And this is a kind of a second implementation of one of the common libraries that you'll find in Linux distributions. And it's used quite a lot in base Docker images like Alpine. So this one here. And Alpine's really popular because it is it's really small, it's quite fast, and it has a good selection of tools built in that you can install with these tools with APK add. So there's a good range of tools there that can be installed, but it is built around this muscle libc library. And this is significant because we don't actually have a muscle build of Calamari. So even if a Docker image based on Alpine had all the other dependencies required for .NET Core, we still couldn't run Calamari in it. And this is also significant because a huge number of third-party Docker images are based around Alpine, and we just don't have a version of Calamari that's going to run on this. So to show you how some of these things play out, or some of the errors that people might see or report, I've got a script example here. So this is just going to echo something to the terminal, or that's the intention anyway. So if this worked, we'd expect to see this text success in the logs. But what I've tried to do here is run this in the context of an existing container. And in this case, I've just picked a Terraform container. And there's a couple of reasons why this is not going to work with the current version of Octopus, and may not work actually ever. It's certainly not our roadmap to provide a solution to make these third-party containers work. And so the first one is that I believe this container is actually based on Alpine. So it just would never have the capability of running the current version of Calamari in it. The other thing is that it defines an entry point, and we don't override those entry points. So if I go in here, sure this one was a right. So this is the Docker inspect of that same image. If we look at config, we should see that it also defines an entry point. So the purpose of this Docker image from HashiCorp is to be able to run Terraform, much like you'd run Terraform from a command line executable. And so to do that, they've defined this entry point here. And so we can see how that plays out when I try and use this container. So had the container worked as we'd expect, what would happen is Calamari would get mounted as a directory inside the container. We would execute Calamari, and then it would run the script that we defined. But we'll see actually get none of that. Okay, that might take a little bit, but I've actually got a run previously. Let's grab this one. So what's happened is that Octopus has attempted to use that Docker image as the environment in which the worker and which Calamari is run. But because we don't overwrite the entry point, all that's happened is we've called Terraform with no arguments, which in this case just defaults to displaying the help. And so this is very, unless you understand the inner workings of Docker and how these entry point the definitions work, this would be really confusing. This is not what you'd expect to happen at all. But because what's happened here is that the Terraform image has that entry point, Octopus hasn't overwritten the entry point, and so that Terraform executable that was defined as the entry point is just the thing that got executed, and it's displayed these arguments here, and then returned an error code, and the whole thing's failed.
Hey, sorry, I'm not super clear on why we don't overwrite the entry point.
Yeah, that's a good question. I suspect it just didn't come up. We probably should at some point. I mean, it does make sense to kind of clear that out. And maybe it's something we'll do in the future versions of Octopus. But certainly in 20.5 is where the EAP flag of this got removed. And yeah, so I'm pretty sure today we don't override that entry point.
Okay.
And so the version where this goes out live, it does have that limitation. We may address it in the future, but I suspect a couple of people are going to be tripped up by this until that happens.
Yeah, cool. Thanks.
Let me go back. The other thing is you can run these worker images as part of Terraform as well. And so this is where it starts. This is where people, I think, are going to try and pull in these official tools as their base image, thinking that it will work. And again, if we look at the output of this, we'll see that you get the same kind of thing. It just it runs that entry point and doesn't work and fails. But this one would be a little bit harder to debug because it's a Terraform step. It kind of looks like it's running Terraform, so maybe it's sort of doing what it should be. But it's the same problem. Again, we've just called the Terraform entry point. We've never executed Calamari, and we've actually just called the Terraform executable provided by that Docker image without any of the proper arguments. So this is something to watch out for because it can kind of look like things are sort of working as you expect, but they're really not. So getting these logs and understanding that relationship between the worker images and the entry point is useful. And so the other thing that we then need to be aware of is the combination of tools that Octopus expects, and these are often uh, not not documented anywhere. So if we went back to the Helm example, I imagine there's actually a Helm Docker image somewhere. Helm. Everyone seems to supply one. Yeah, it's probably this one. So you may think that grabbing a Docker image like this that embeds Helm into it would be a good solution for the for a Helm step, but it's actually not. And again, I imagine I haven't actually dug into this one, but I imagine it actually defines an entry point, just like all the other ones do. And we can see from the name it's based on Alpine, so that's another red flag that tells us it's not going to work. But the other reason why it's not going to work is because of those combination of executables that we need. We need Helm, we need kubectl, and we need quite often a cloud-specific authentication executable as well. And all of those tools need to be available in the one image. And these base images really, I've never seen one of them provide that particular combination. So what you may find is if someone selected a Docker image like this, tried to put it into Helm, and they were deploying to a cloud-based Kubernetes cluster, authentication may fail, or there may be some errors saying, we expected these executables or this environment to be set up for us, and it just wasn't there. So even if this image had all the other features that we're looking at, it didn't have an entry point, it wasn't based on Alpine, and it, for whatever reason, just coincidentally happened to have all the dependencies required for .NET Core to run, you'd still probably run into trouble where just some of these combinations of executables aren't present in the way that Octopus expects. So I think some of the takeaways here are that Docker has this mentality of being something you can run everywhere, and that's not quite true for our implementation here. In fact, it's mostly not true. It'd be I think it would be coincidental that people could grab a Docker image built by a third party and it would actually work as you expect. That would be kind of a fluke rather than the norm. So we specifically we know there's a bunch of limitations in our implementation. So we're not going to support, or we'd have no support today for anything based on those muscle images, which rules out anything from Alpine. We don't override the entry point, so that also rules out a whole bunch of these third-party images. The dependencies required by .NET Core quite often aren't available, and again, that rules out a lot of these base images. And it's a combination of those tools that are perhaps not obvious that you'll almost never find in third-party tools that will also trip people up. So the advice I think we need to give going forward is try and default to these tools here, or these images here. They're obviously customized to do or solve the problem that we wanted to solve, and have all the dependencies and have all the executables and all the combinations that we expect. If they're not quite what you need, you can create your own images and usually base them off our own sort of base images here. So if we look at, so you could actually grab this, and for Docker, you do something like from Octopus Work Tools, and that would start you off from a tool that we know works. And then you could go ahead and install any particular versions of tools that you need, or any additional tools that you need. We do also have, if we jump into the Docker files here, these will take us to the source code. And so this is how we build up our base images. So if people really need deep levels of customization, they could take these Docker files and edit them for their own purposes, and that would give them a good kind of a good shot at creating a Docker image, a custom Docker image that supports their use case. That would be quite advanced, though. I'm struggling to think of a typical use case where you'd go to this level, but it may be that that is where people get to, and basing it off this code here is what they need as a template to achieve that. Yeah, so I think really just what I wanted to drive home here was that I do expect support tickets to come through where people have attempted to throw in unsuitable images here, and it doesn't work for a variety of reasons, and the reasons are probably not going to be obvious to anyone who expects our implementation of this to work the way Docker kind of promotes itself as working. And we really, certainly with the implementation we have now, we should be pushing people towards using these base images, basing their customizations off these base images, or I mean, if they really have to, they can look at our Docker files as a template that they can work from. And that's it. That's all I wanted to show off for this particular workshop. So any questions you had?
No, that's great. Thank you.
Okay. All right. I'll put the recording up when it's done, and I will catch you next time.
Cool. Have a good day. Thanks.
All right. Thank you. See ya.